Hello viewers, I'm Praveen, working in a software industry for the last 25 years. In this course, you will be learning C++ uniquely through question and answer sessions. And this we will take up in 5 modules. And as we move from module 1 towards module 5, we will learn the concepts in greater details. So let us begin with module 1. So this is the first question. Explain the structure of C++ program. Mention the application of C++ programming language. A typical C program would contain 4 sections as shown. That is, it is going to have an include section, a class declaration section, an in-class declaration. Inside the class you would have member function and even maybe data members, and outside the class you will have the main function program. So the include file, what is the include file? In the C++ programming language, the hash include directive, it's a preprocessor basically. So the hash include directive tells the preprocessor to insert the content of another file, the file name that you have given, insert the content of another file into the source code at that point where the include directive is found. Include directives are typically used to include the C++ header files. For C++ functions that are held outside of the current source file. So what does that mean is, so the header files are to tell you, in your programs you have some functions whose the current source, whose details are not available basically. So the details of that is available in the header file, and so you insert that particular file, header file, in your program. So a typical declaration is going to be as below. The syntax for hash include directive in the C++ language is something like this. So hash include, and you will have the opening bracket, you will have the less than sign, then you will have the header file name, then you will have a greater than sign. Or you could also have it like this, include, and you can actually have it in between 2 quotes. Basically the difference between them is, whenever you have a header file which is enclosed between the greater than and less than and a greater than sign, the compiler goes and searches that file first in the include directory where all the source files are available basically. And if you actually give in double quote, then what the compiler does is it goes and searches in your source file. It will not search in the C++ compiler include files location. It will search in your source file location and for the particular file. Now the program, the header files are enclosed in double quotes when you have written the header files and you want to include that in your program. So a client server model of the same, how the structure is. So from a client server perspective, the class is working like a client, and the main function is the class is working like a server, and the main function is working like a client. So the server is available and for the client to use it basically. So that is the concept for this client server model of the structure. Let's again understand more in more clearer details this particular files. The include file is a pre-processing directives, a line of a program which starts with hash. So all the pre-processing directives or preprocessors starts with hash. Now hash include iostream. If this is a command that you have written, then you are requesting the compiler to include the iostream header file in your program. Now, what exactly this iostream header file has? Like if you are using commands like cin, cout, okay, then these are the commands you are not written a program for cin, cout. The detail of that is available in the iostream file. I'll show you a typical iostream file, so you will understand what is inside them. So here we have one. This is as you see, it is iostream file basically. So what this has is, it has already included one file called ostream and istream. You also have those ostream and istream file, and all the details of that ostream and istream is already included in iostream. So if you are including iostream, you don't have to include the ostream and istream. So okay, other than the ostream and istream detail, what else this is having? So you can see here, this particular header file is having the detail of cin, cout and cerr and clog. So if at all you are using any of these commands, then you will have to include iostream.h or iostream, basically include iostream. Now similarly, you can see the include subdirectory have header files like the include subdirectory in your compiler basically. So if you are using a GCC compiler, you would have to get to the details of the include subdirectory of the GCC compiler or any other compiler that you are using. So the include subdirectory of your compiler, you will have header files like iostream, you will have fstream for file related details, you will have string for all string related functions, then you will have set for set with, like you want to set the output in particular number of bits, bytes, and the format in which you want to set the output. So you can use, if you want to set that format, then you will have to use set header file. And if you are using stack, then you can use a stack header file. If you are using list, then you can use list header files. If you are using queue, then you can use queue header files, and mat functions, etc., etc. So you have all these header files in C++. You also have more than this. I've just given examples. So the next is a class declaration. So for that, first we will understand what is a class. A class is a user-defined data type which has data members and member functions. The data members are the data variables and member functions are the function used to manipulate these variables. And together, the data member and the member function defines the property and behavior of the object in a class. Okay, we will get into more details about the class, but I'll just make you understand a little bit about it in the next slide. So here you have a typical structure of a class. So a class is a class name, and you begin with a class basically to start giving a class name. Then you give a class name, and from this bracket till this end of this bracket, and it ends with a semicolon, this complete is a class. So inside the class you will have an access specifier. We'll get into that in the coming modules. Then you have something called data members and member functions. The data members are something, all the variables like integer, float, all the variables you will declare which you are going to use inside this class. And the member functions are one which are going to store the value into the data member, that is the variables, and take the value and probably give it outside this class itself. So those functions are called as the member functions. So here a typical definition of a member function and a main function is here. So a member function of a class is a function that has its definition or its prototype within the class definition, like any other variable. So it operates on any objects of the class of which it is a member and has access to all the members of the class for that object. So this data member function will have access to all the data members of that particular class. The third one is the fourth one is basically the main function. Now a main function, a C++ program is a C++ program always starts from calling from main. So it's a main function is the first programs that executes. Okay. In fact, main is the only function called automatically. So any other function you will have to call, but this is automatically called. It's a first program automatically executes, and the code in any other function is only executed if its functions are called from the main. So if you look at our question, okay, let's go back to our question. Explain the structure of C++ program which you have understood. Mention the application of C++ programming language. So let us look at the application of C++ programming language. Now C++ is a versatile language for handling very large programs. It is suitable for virtually any programming task, including development of editors, compilers, database, communication system. You can do anything, any application, whatever C was doing, you could use it for everything. Since C++ allows us to create hierarchical objects, we can build special object-oriented libraries which can be used later by many programs. While C++ is able to map the real-world problem properly, the C part of C++ gives the language the ability to get close to machine language details. So it can do everything what the C does basically, but it is having an added feature. You can write a program which is more maintainable, more easily expandable, and that is the advantage of C++. And these are the applications that you can have, like editor, compiler, database, communication system. You can write any program with the C++. So our next question is, list the different data types used in C++. Give example for each data type. So let us list the data types used in C++. Now broadly, the C++ data types can be defined into three different types. So the center one, which you can call it as a built-in type, or you can call it as a basic data type, or you can call it as a standard data type. So this is the built-in, which is already directly the basic data type available in the language compiler. So you have in the basic or built-in or standard data type, you have something like integers or integral types. Then you have a void type and you have a float type. Then you have other one is a user defined data type and a derived data type. Now let us first look at the derived data type. So let us go next to our slide and we will come to know here more in detail. So you see here in derived data type you have arrays, functions, pointers and references. We'll get into the detail, we'll understand them in more detail going forward in the next few slides. And the third one you have is a user defined types like a structure, union, you just saw a class, and enumeration data types. So let us look at the built-in type or a basic data type or a standard data type first. So this standard or built-in or basic data types are data types for which the programming language provides built-in support. The data type are provided by C++ compiler as basic building blocks. It is used to handle only one value at a time by using single definition. So if you have an integer, you can store one integer. If you have one float, if you have a float, so integer I means you can store some value like 10, 20 in the integer I. You can store any value, but you can store only one value in the integer I. If you have a float f, then the f can have any value with a decimal point, but only one value. The void data type is basically, it's an empty argument. So if at all you don't want to return anything from the function, you will use a void data type. If you want an integer to return from the function, you will use int the function name. Void and function name means the function is not going to return anything. If you have any other like a string and the function name, it is going to return a string basically. The next one is the derived or extended data type. Now these derived data types are used to extend the behavior of the existing simple data type. These are also built into the system, so it's of the same type basically. The data type is of the same type. So derived data type are used to extend the behavior of an existing simple data type to get more functionality. It is used to handle more than one value at a time using a single identifier. The various derived data type provided by C++ are arrays. Then you have functions, references and pointers. Now array is the set of element of a same data type. So like if you have an array of integer, then you can have a set of integers. So if you have an array of 10 dimensions of 10 subscripts basically, then it can hold a 10 values from 10 different values of integer if it is integer data type. All elements in arrays are stored in a continuous memory locations, and each element is accessed by a unique index. So every array value can be accessed by an index value like array of 0, an array of 1 or array of 2 and array of 3, etc. So the subscript index, which is called as a subscript, the subscript value indicates the position of the element in the array. The second derived data type is function. Function is a self-contained program segment that carries out a specific well-defined task. So you have some particular well-defined task, then you would want that task to be separately, so you want that program to do that task. So it is a self-contained program segment that carries out a specific well-defined task. In C++, every program contains one or more functions which can be invoked from other part of the program. The third one is a reference data type. In a reference data type, is an alias for a variable in a program. So with something like you are telling, okay, you have an integer I and you have integer j which is referring to I. So if j is referring to I, then if I value keeps on changing, j value is automatically changing because it's just referring to I. And if j's value is changed, the I value is also changed, because j is referring to I. So actually whenever value is changing, it's actually going and changing the value of I. So that is what is the reference data type. And the next one is a pointer. A pointer is a variable that can store the memory address of the another variable. So it stores the memory address of another variable. Pointer allows to use the memory dynamically. So we will get into these details more in coming slides. So I hope you have understood this derived data types. The next one is a user defined data types. Various user defined data types provided by C++ are structures, unions, enumerations and classes. Structures, unions and classes provide a way to group a similar or dissimilar data type referred to by a single name. So you've already seen this in a class. I will show you in more structure and union also, and I will show you how they differ basically. Next is enumeration data type. A enumeration data type is a set of named integer constant that specify all the permissible values that can be assigned to a enumeration variable. These set of permissible values are known as enumerators. For example, consider the statement enum country. So the country variable can have UK, USA, France, India and China. It has all these. So only these you want to enumerate. Then you can use a enumeration data type. I'll show you with an example so you will understand in greater details. So let me show you one example for structures unions first. So you have a structure in union. So this is, if you look at this program, you will understand. So we have declared a union here, and then we have declared a structure. This union is similar to the class that you would have seen, but it doesn't have an access specifier, and it is you have three variables declared inside the union. The same three variables are declared inside a structure. Now the difference between the union and the structure is, though if you look at them, you may be able to see that they are almost the same, except this particular union and the structure. Except this particular change, everything else is same. Now what is the difference between them is, whenever you declare a structure, the compiler makes space for three data types. Basically you have declared character array of 16 bytes, that is 16 characters. Then you have declared one float, salary, and then you have declared one integer, that is worker number. So the same thing you have declared for union. For union also it is declared the same. So we have declared character array name of 16 bytes or 16 characters, and then you have a float which is a salary, which is of float type, and a worker number, which is of an integer type. Now in union, what it actually does is, it will find out what is the highest, which is a variable which wants the highest space. So here it's character name, which is of 16 bytes basically, or 16 characters. The float wants 4 bytes and the integer wants 4 bytes. So the union will actually allocate 16 bytes of space, and it will allow you to store only one of these variables, not all of them. Whereas in a structure, you can actually store value for all three of them, because it allocates space 16 plus 4 plus 4, that is 24 bytes of space. Now I've written a program just to understand what is the size it is actually doing. So here you can see out size of union, and I'm just writing size of, that is U job, that is union job, and this is structure job, then size of S job. Now let us run this program and check. So I will compile this and execute it. Now you can see exactly as I told you, the size of union is 16 bytes because that's the maximum size you can have in a. So whatever is the maximum variable, that is the size it allocates. Whereas for a structure, it is allocated 24 bytes. So I hope it's very clear, like the difference between the union and the structure. Now I will make some dynamic changes and make you understand. Example, you have a union of this particular structure. So what you do, what if we have something like I'm declaring two more union data type here. And let's compile this now. Sorry. So it's compiled. So in spite of declaring, it's still giving only 16 byte of space. So what it exactly means is you have three unions actually. You have one is this one, then you have another union job one, then you have another union job 2. But out of this is a union and this is a union, and these are all, it takes each one of them as a different data type, and it will allocate only 16 byte of space. Now instead of union, if you have a structure, now what will happen in that case? So if the same thing, if we do it in the structure, okay, I'm compiling it, and execute this. Now you see the size of the structure has become 72. So I am very sure it is very clear to you how this structures and unions are working. Now let us see how the class is different from this. So I've deleted the extra thing. If you declare in place of structure, if you declare it as just a class, okay, and instead of this I'll just change the union as a class, okay, and let us call this, okay, and let us compile this. Okay, something is left over from, okay, it sounds successfully compiled. So you can see now we should have changed this. This is actually the class data, and it is actually the same 24 bytes. So the size of the class is 24, the size of the structure is also 24. Then how they are different? Now if I want to access, I want to store a value into the, I want to use a value. So if I try to use this and I tell okay, something like out, okay, I'll just tell worker number is equal to 10, and then if I actually print that, so I can actually print this one. So it's compiled, execute, sorry, I didn't build it, so I'm building it and execute. So now you can see the structure worker number is equal to 10. So that's the value what we have stored. In the same place, now this is called as uJob, okay, which is a class basically. If I try to store the same, instead of if I try to store value into uJobs, what is going to happen? Compilation failed. So why the compilation has failed? Let us look into that. So you can see here, so in Union Jobs, okay, we just didn't change the name. This is actually a class now, Union Job. In Union Job, the worker number is private. So this is actually a private. So the difference between the structure and the class is, by default, all of this is public, whereas by default in class, all the data members are private. So if you actually just make it public, then they are both same. Yes, we have compiled successfully. So we can actually print the value of the class also. So you can see that class worker number is 20. So we are able to store the value into the class. So I hope you have understood very clearly the difference between the structure, class and the union. So let us go back to our program. So next is a enumeration data type. A enumeration is a set of named integers, constants, that specify all permissible values. Now, I'll show you through an example basically the enumeration data type. So we have an example here, and we have declared a enum called week, and the week actually starts with, you have not declared anything. Okay, so you have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and then you tell then you tell day is equal to, you have declared the enum type week and you have declared one day, and then you tell day is equal to Thursday. What you are doing next is you are printing that particular day. This is not printing that. This is required now. Compile, build, and execute. So now you see what has happened. Because it's Thursday, so automatically the value of Sunday is 0, 1, 2, 3 and 4. So you told day is equal to Thursday, and we are actually trying to print the value of the day which we have assigned as a Thursday, and it is giving weekday number is equal to 4. Now in case you want to change the order, or you want to make it something like you want to start it from 1, so Sunday 1, so then what is going to happen? Now you can see the weekday, because by default it starts with 0. The first value is taken as a 0. But if you give first value as 1, then subsequent values it increments 1 by 1. So the enum for Thursday becomes 5. So weekday number is 5. Now what would happen in case if I give the next value as as 10, and I give something like this one. So then it is 20. If Tuesday is 20, 21, 22 is going to be the value of Thursday. So you see, weekday value is 22. Now in case if you want to do something like this, you want to add the value of Thursday and Sunday. So what is going to happen? Now what is the value of 22 is the value of Thursday. And if you add 1 to that, it is going to be 23. So let us see whether it's going to be, so we will have to declare the variable I, integer I, and then we will have to print the variable I. So let us check. So you can see the value of Thursday plus Sunday is 23. So I hope this example was good and you were able to understand the enumeration data type. Our next question is, what are variables? With syntax, explain declaration and initialization of variables in C++. A variable provides us with a named storage that a program can manipulate. Each variable in C++ has a specific type, which determines the size and the layout of the variable in memory. The range of the values that can be stored within the memory and the set of operations that can be applied to the variable. A typical syntax is, you will have the first is type declaration, whether it is integer, float and all, whatever you want, and then you will have the variable name, and if at all you want to initialize the value, then it equal to the value. Here you can see some variable declaration and initializations. So here you can see integer a, b, integer c, float f, etc. Here you can see A is equal to 10, B is equal to 20, and C is equal to A plus B. So these are some examples. I'll show you with some example. Variables. Syntax, explain, declaration, and initialization. I think this is good enough. Mention different types of operators used in C++. Explain increment and decrement operator with examples. So let us see what are the different types of operators. So in C++ you have assignment operator, you have a bitwise operator, you have a shift operator, you have a unary operator, ternary operator, comma operator, relational operator, logical operator, mathematical operator. So these are the different operators that you have in C++. Now you can see here what is the assignment operator. This assignment operator is where A is equal to B. So the value of B is going to be the value of A, or A is equal to 2. So A value becomes 2. You are assigning 2 to the A. A plus is equal to B means you are adding the value of A and B. So if A is 2 and B is 2 and A plus is equal to B means A is going to become 4. If A is 2 and B is 2 and you make A minus is equal to B, so A value becomes 0. If A is 2 and B is 2 and you have A multiplication is equal to 0, something like this, then the A value is going to become 2 to the 4. And again, if A's divide is equal to, so A value becomes 1. A mod is equal to B means A value becomes 0. So if there is no remainder, this percentage is nothing but a mod operator, the modulus operator, which if there is any remainder, that is what is going to be the value. So I have here I have written in more detail, and I will show you with some example all these operators what I have shown you. So here you can see a program is there wherein I declare an integer 20, A as 20 and B as 10. And what I do is I used a unary operator. If you look at this, a unary operator, that is plus plus. Incrementing, this is called as a unary operator, that is plus plus A and minus minus A. So what exactly this is doing is it is going to increment first the value of A and then assign it to C. Here what it is going to do is first decrement the value of A and then assign it to C. So here the C value is going to be 21 and here the C value is going to be 20, because here it will increment and then assign. So from 20, as A value is 20, it becomes 21 and as get assigned to C. And in this location it's going to actually C value is automatically first going to get decreased back to 20 and then get assigned to C. Here you are 20 plus 10, that is going to be 30. This is going to be 20 minus 10, that is going to be 10, and this is 20 into 10, that is going to be 200. This is going to be 20 divided by 10, that is going to be 2, and 20 mod 10, which is going to be 0. So let us see, let us execute a run check. So you can see the value is 21, 20, this value, okay, it is incremented, A is incremented and then assigned, A is decremented and then assigned to C. Here A plus B, A minus B, A into B, and modulus is here. So this is it. So you understood the program. We start the program with the include iostream because we are using cout, and then using namespace std we are making the standard library for in a global space. Then we are starting our main program. This is our main program. Okay, and here we are declaring I and B, that are integer A, B and C, and accordingly. So you have understood this program, I hope. Let us look at the next. So these are some of the operators like assignment operator, bitwise operator. So you have seen many of these operators, but now I will show you some bitwise operations. The bitwise operators these are actually when if you are manipulating the bit. So you want to do some bitwise addition, then you have to use this ampersand basically. So this is actually tells you are doing AND operations on the number, and if you use only one line like this, then it is actually a OR operator. And if you are using this one, it's a XOR operation, and this is for NOT operations. So and using two less than signs together, it's a shift operator. So you are shifting the bits to the left, and by using two greater than signs, you are actually shifting the bits to the right. I will show you all with the example, and I have already shown you unary operators and the ternary operator, which is actually the question mark, and you will have some conditions over here, and then you have a condition over here, and if whatever is based on the condition, it's something like this. I'll explain to you. You have like A is greater than B. Now if this condition becomes true, then you can tell C out. Okay, you can write some A big. Then you will have to use colon, and then you tell C out B big. So basically you can see in only one line you are able to do the condition. So you do the condition over here, and based on this condition you are writing if the condition becomes true. So before the colon and in between this question mark, you are actually doing the operation ternary operator, that is if it is true, and if it is false after the colon you are writing that, and that becomes a false condition. So it's something like this. So let me show you some bitwise operations and make you understand. So I have a program here. So this is a bitwise for bitwise operations. It's the same like I started with include iostream. I've included iostream file. Then I made the namespace for a global space. So because I use C out, and I've declared a variable called m, which is 40, and another n, which is 80, whose value is 80. I have also declared some variables, integer variables like AND operation, OR operation, XOR operation, NOT operations. Okay, these are only to store the values of these operations basically. So I have declared those variables. Now because this is 40, this is a program for bitwise operations. I have written here the value of 40, how the bits are going to be arranged. So you can see this is 0, this is 1, 2, 4, 8. So the 8 is 1, and then 16, this 32 is 1. So 32 plus 8, it becomes 40. So this is 40 basically. So this is how the values are. And then this is 80. When you assign 80, actually the values goes like this. And you can see this is a bit which is unable because the value of this bit is 16, and this is a bit again is unable. The value of this bit is 64. So 64 plus 16 is 80. Now whenever you are doing an AND operations on this, what is going to happen? If you are doing an AND operations between m and n, it what AND wants is it wants both the values to be 1. So you in none of the locations you will find the value to be 1. So this is basically going to print 0 because the everything is 0. Basically all the values are coming 0. The next one is OR. So what OR does is, whether it is 0 or 1, wherever 1 is there, it's going to become 1. So it basically becomes 1, 1, 1, 1, which is nothing but 120. So it's 80 plus, so it's going to become 120. Now you have a NOT operation. What the NOT operator is? The NOT operator is exactly going to do the reverse. It's going to, so if it's a NOT of what we are trying to do, NOT of this 40. Now we will have to, because this is a 32-bit, it's going to have a different value. So let's again, and we will look at the XOR values. So what the XOR wants? The XOR wants, if either of them is 1, then the value is 1. So if either of them, so if these both are 1, if this is going to be 1, so what is the value we are expecting? We'll run this and check the values. Okay, the next one is, I didn't tell you about the shift operator. Now if we are going to shift M, which is 40, so if this is a value, if this is it, okay, when you shift it, basically what happens is, you are actually shifting this one and putting it here. Okay, so basically it has become, now you can see the value is similar to the 80, so it is actually made it 80 when you're shifting to the left. Now again, if at all you are actually shifting the value of M to the right, what you are exactly doing is removing this and adding this 0 here. So what you have actually done is, this has become 16 plus 4, which is actually 20. So let us see the values now. Build and execute. So this is exactly the values with what we were expecting. Okay, the XOR is also exactly, we were expecting 120, and that is what it is. So you can see this is 0, this is 120. XOR also we were expecting 120. The left, whenever you are moving to the left, you are getting 80, and when you are shifting to the right, you are making it 20. So I hope this is clear to you. Bitwise operations with this. So I have shown you an example for the bitwise operation. I explained to you the shift operators as well. The unary operator also I have explained to you. Okay, so let's go to the next question. What are control structures? Write a simple C++ program to demonstrate for loops. Okay, so first let us see what are the different control structures. The different control structures in C++ is switch, like you want to select one of them based on the switch value. So the switch case statements, you have switch, you have if else, while, do while, and for. Now let me explain to you this. Okay. So let us see from the, let's begin with the if and else statement. So if you look at this program, this one, if x is equal to 0, then you will actually, then you are going to print out. So x value has to be this is a relational operator for checking whether the value is the value is same or whether the values are matching basically. So you are checking the condition. So if x is equal to 100, so in case if the value of x is equal to 100, then it's going to print x is equal to 100. But it's a good practice to use brackets like this, because this is a industry practice. It's compulsory to use a bracket. But the compiler supports you if it will not give you error in case if you have only one statement and you have not put a bracket. Now in case if you also want to know, in case if this condition is not true, then you want to check something else, or you want to give something else. You can see here the example. If x is equal to 100, you want to see out x is equal to 100. Else you tell x is not 100. So you can use the else operator in that place. So you can also have like if, else, and again you can check another if. So else if, and you can go on basically like that. So if x is greater than 0, then you tell x is positive number. Else if x is less than 0, then you tell x is a negative number. Else you tell x is a 0. So if it's 0, then only it's going to come to this condition. So this is about the if statements. And as we have seen, you have something like while. I can show you all these with some examples here. Now I will execute this example and show you. This is you can just see here. This is integer n, and you are telling enter the starting number, so you can give some number. And while n is greater than 0, so you are going on decrementing in the while loop. You are going on decrementing and you are outputting the number. So you can just see if you enter 8, it is becoming 8, 7, 6, 5, 4, 3, 2, 1, and then it's printing 5. Something like this. Okay, so based on whatever number you have given, it is actually going to print. This is going to be the output for that. So I hope you have understood this clearly. So if you can also make this do while, where you are checking the condition on initially. You can also check the condition at the end. That is, you can check the condition like do and while. The difference between while and do while is, in while the condition is first tested. So if the condition fails, then it may not enter the loop at all. So in case if n is greater than 0, okay, then it is going to enter the loop. But if at all if n is already less than 0, then it may not enter the loop. But in do while loop, whatever the condition, it will enter the loop at least once. So I think we have that condition here. Now see here, this is a program we have, and here you can see do while loop. So enter the number 0. Now here if you check here in this program, you are entering the value. Before entering the while loop, you are accepting the value. But here in this case, though you are not having any n value, you're still entering the loop, you're accepting the value of n, and you're starting the loop. So you're accepting the value of n, then you start, and so you can enter the loop if n is not equal to 0. So as long as you don't give 0, it will keep on asking the value. So enter the number 0 to n, and you can keep on giving number, and it will keep on entering the number you entered, and it's going to go on printing as long as you have not entered 0. So once you've entered 0, okay, it enters and it checks here while n is not equal to 0. So the moment you enter 0, it will come out of the loop. So this is a do while loop. The next one is a for loop. In the for loop, what you have first, in a for loop you have first is an initialization wherein you tell I is equal to 0 or j is equal to 0 or I is equal to 10, whatever number you initialize the value. The next one is you have a condition. So I is equal to 0 and I is less than 10. So as long as I is less than 10, it's going to go on here. And then you tell you want to increment, so you tell I plus plus. So with every iteration, with every loop, it will increase the value of I. So you just see here, this is the program. So you tell n is equal to 0 and n is greater than 0. That is a condition. As long as n is greater than 0, it has to go on in the loop. So this is a loop. It will go on. This is only statement that is that. So you tell it starts with 10 and it will go on decrementing with every iteration n value by 1. And here you are checking. So the n is greater than 0. So if n value is greater than 0, then it continues in the loop. These are the for loop. So the first one is a declaration, and after that you have a semicolon. Then you have a condition. Then you have again a semicolon. Then you have a increase or decrease, whatever you want to increase or decrease the value. So you can just see here 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So this is what has printed. Now you can also have something like break, continue and go to statements. So what is a break? If you have a loop and whatever the condition you want, whenever a break executes, it just comes out of the loop. So even if your condition is not true, so you have a loop here wherein n is equal to 10 and n is greater than 0, n minus minus, and it will go on. If this condition was not there, then what would have happened is it would have executed. I will execute this and show you. It will go on executing this till the value becomes 3. Now if this condition was not there, it would have actually printed till n is greater than 0. So it would have printed till n 0 and then come out of the loop. But now we have if n is equal to 3, then we are told we have written a statement called break. So this is a print countdown aborted, and you just break. So countdown aborted, you can see here also, and it is break. Break means it will just come out of the loop. Now sometimes you don't want to come out of the loop. You don't want to execute the other part of the code. Okay, so you can just see here. This is a different another program which is with the continue operator. So in continue operator, what you are doing, your if I is equal to n is equal to 10, and if n is greater than 0, n minus minus, and if n is equal to 5, continue. So only if n is equal to 5, continue. So you don't want to execute this C out if the n is equal to 5. So it will execute continue, and it will, the moment it encounters continue, it will go and execute. It will skip the remaining part of the loop, and it will again start from the top of the loop. So you can just see here 10, 9, 8, 7, 6 is there, 5 is not there, 4, 3, 2, 1 is there. Okay, so this is how the continue operator works. The go to operator will actually jump from the program to the label. So you can see here, this is the go to operator is used here. So you have something like n is equal to 0, C out n, and you go on minus a. So if n is greater than 0, you go back to this loop. So what we are exactly doing is the same thing. We are actually doing something like what this for loop was doing. You are checking here, if n is greater than 0, then you go back here, and again you go back as long as it's 0. So this is, you can jump from anywhere to anywhere in the program using goto, but it's not a good practice to use goto in program. But you can always use it in the exceptional case you want to use it. You have a circumstance like that, then you can definitely use it. The exit program aborts the program. So exit is a function defined in cstdlib library. The purpose of exit is to terminate the current program with a specific exit code. So this is a exit. The next one is a switch. The switch is like, the syntax for the switch statement is a bit peculiar. Its objective is to check several possible constant values for an expression. Sometimes similar to what we did at the beginning of the session, and with concatenation of several if and else if. So it is actually doing like several if else if kind of a work. So here that we have, there is an example over here. So how it is working: if x is equal to 1, then execute this. Else if x is equal to 2, then execute this. Else if x is 0. So it switches similar here. So switch, then you, whatever the x value is, if x is 1, it is going to execute this. But after that, you have a break. So it doesn't execute the case 2. If you don't have a break, it may continue executing the next one also. Then if the x value is 2, then it will not execute this one. It will directly come to the case 2 and execute this one. And if none of the values are true, then it will execute this one. So that's in the control loop. Control statements. The next one is how objects are passed as parameter to the member function of a class. Discuss with example. So here in the next program, how objects are passed as parameters. I'll give you one beautiful first illustration, like how exactly it happens. You have a class and you have a member function inside. So if you have a member function, then you have a function name. You specify the class and the variable names. Again, you can specify the class and the variable names. So whenever you are making a class, now here in the main function you have three variables, O1, O2, O3, and you tell O1 dot function name is equal to O2 plus O2 comma O3. So you are sending the value of O2 and O3 to the O1. So the O1 will get the value, will receive the object O2 in the form of AGR1, and it will receive the object of O3 in the form of ARG2. So I'll show you with an example, and then it will become more clearer. So here is an example. I'll just make one integer variable, okay, and it will set the value of a, and you can sum and you can print. So what is done in the main program? This is a class. So this is the member function, integer, and data members, and this is member function. Set is the name. This is a member function, set. This is another member function, sum. In this one, as this is a class demo, so you can see here the demo is sent as a variable or argument to this particular function. So two class or two objects are sent as argument to this particular sum function. So then the obj1 becomes the first object, and object 1 dot a, you are actually again referring to the object 1's a value. Then you are referring to the object 2's a value, and you are assigning to the object 3, which is whichever the object has called this. So object 3's a value. So let us see this, and we will come to know more clearer. Demo, you tell d1, d2 and d3. These are three objects that are declared, and you tell d1 dot set, and we are giving 10 and 20 as value, and then from d3 dot sum is equal to d1 and d2. Then we are printing the value of d1, d2 and d3. So here every time what it does is it just prints the value of d1, d2 and d3, whichever print function we are calling. So it will print that particular value. Let us run this and check. So build and execute. So you can just see we have not assigned any value to the third object. What we have assigned, we have assigned 10 value to the first object, 20 value to the second object, and the third object actually adds the value of the first object and the second object and assigns it to itself. So we are printing the value of third objects and it is 30. So I hope you might have understood this clearly. Thank you, viewers. If you have enjoyed learning, then please like, share and subscribe our channel. Thank you.